Hi folks, in this video I'm going to go through the code that I used for creating Pong in PyGame. I'll run the code just to show you what the finished game looks like. So I've got some counters at the top for the score, and I've got a ball speed and an input for starting the game. So I'm moving the paddle on the right hand side myself with the up and down arrow keys. The paddle on the left is completely controlled by the AI, so it tracks the movement of the ball and moves up and down to try and meet it and knock the ball back to me. And additionally, I've added in some game over conditions, and as you can see, there's collision working off the top and bottom of the screen as well as off the paddles. So I'll close that down, and I'll open up a new window here, and I'll just go straight into the code. So first of all, as always, start off with importing the libraries. So import PyGame, and from PyGame locals, import star. And after that, we want to initialize PyGame, pygame.init. And now I want to create my game window. I'm going to give it a screen width of 600 pixels, a screen height of 500 pixels. And now I can create the game window, which I'll assign to a variable called screen. So whenever I call my display, I'm going to use the screen variable. So for this, I use the pygame.display set_mode function. And into this, I feed in the screen width and the screen height. And then on top of that, I want to add in a caption for the screen, so it doesn't just say it's an untitled window. So it's going to be pygame.display set_caption. And I'm just going to put in Pong. So now I can come down and create my actual game loop. Create game loop, and I'll set an initial running variable, which I'll set to true, and then I'll just say while run, meaning that as long as this condition is true, the game loop is going to continue running. Into this game loop now, I'm going to put in my first event handler. So I'm going to iterate through all the events from PyGame. So for event in pygame.event.get. So this is going to constantly run through the event handler through PyGame, and it's going to tell me what event has happened. So the first one I want to look for is if event.type equals PyGame quit, which means if the quit button or the X in the top right of the window has been clicked. So if that's happened, then I want to set my run variable to false, and that's going to essentially end this loop, and it's going to end the program. So lastly then, I want to deinitialize everything, and that's going to be pygame.quit. Alright, so let's run this just to check it's working. And I've made a typo here. Okay, let's try again. There we go. It creates the window, and at the moment it's just a blank game window. So the next thing I want to do is actually add a color and add some kind of background to this, and show on some lines and essentially make my game board. And to do that, I'm going to define a new function up here. This will be define draw board. And in this function, all I'm going to do is fill the screen with a background, and I'm going to draw that horizontal line which kind of demarcates the game area from the scoreboard area. So prior to doing that, I want to define a couple of colors. Define colors. And for now, I'm going to set a background color, which I've chosen previously, so I'm just going to type it out here. And I'm going to also have to define white, because these colors aren't automatically defined within PyGame. So now I can come down here, and the first thing I want to do is draw the background. So I'm simply going to fill my original screen. So I call the screen variable screen.fill, and I'm going to input the background color. Now I want to add that horizontal line that's going to be my demarcation. So that's quite straightforward. Pygame.draw, and this gives you a whole bunch of different shapes that you can draw: rectangles, circles. I'm going to use line. I'm going to apply it to my screen, which is my display. The color is white, and now I need to give it a start and an end point. So the start point is, well, the X position is going from the left to the right of the screen, but the start is essentially a margin. So I'm going to define this height first because it's going to make it easier for me to play around with it if I want to move that margin up and down. So I'll say define game variables. And this is where I'm going to keep the majority of my variables, which I'll add to as the game grows. I'll say margin is 50 pixels, and then I'll come back down here and I'll set my start position. This is going to be an x coordinate of 0 because it's on the left hand side of the screen, and a y coordinate of margin. And the end position is going to be my screen width because it goes all the way across, and margin for the y. And lastly, I'm going to give it a thickness. With that created, I can now call this function within my game loop. I'll say draw board. So that's going to be the first thing that this main while loop is going to call. And to actually get things to update on the screen, I need to call an extra PyGame function. And this is pygame.display.update. What this essentially does is that through the game loop, I'm going to be making a whole bunch of changes. And to actually process these and to show them and display them, this is the line that's going to be doing that work for me. All right, so let's run this again and check. And there we go. I've got the background set and I've got this demarcation line that separates my game area from where my scores are going to be. So let's do that next. I'm going to add in that score counter and all the text to the top of the game. To do that, I'm going to add in another function. This is going to be draw text. It just means that every time I want to draw something or I want to put something on the screen, I don't have to type out all the code that goes with it. I have a function ready-made to go for it. Now in PyGame, before you put any text on the screen, you have to define a font. I'm going to come up here and I'll separate another area for it. Define font. And I'm going to assign it to a font variable. This font is going to be assigned with the function PyGame font.sysfont. And in here, I specify the font. So I've gone with Constantia. You can put whatever you want in here, and the font size. Now that I've got this, I can come down into my draw text function. And to create text, I need to take the actual string and I need to convert it to an image. So my function is going to take a number of variables. The first one is going to be the text that I want to display. Then I want the font. I want the text color, the x and the y coordinates. Now that I've got this function, I can use it to generate images from this text. So the first thing I'm going to do is convert that text to an image using the font.render function. This takes the original text that's been fed into it through the function, and it's going to set a color to it of text color. Actually, I'm just going to rename this text color just to shorten it. And then once I've created that image, I need to display it on the screen. And whenever displaying images, we use the blit function. So the first line or the first section of that is my display window, and then it's .blit. And into here, I put in image, which is the image that's just been created in the line above, and the x and the y coordinates. So now I can use this function within my main loop to essentially put anything or any text onto the screen that I like. So what I want to put on first is the two score counters, so the computer score and the player score. But before I can do that, I have to define these variables first. So again, I'm going to come up to my define game variables section, and I'm going to say my CPU score starts at 0. And the player score also starts at 0. Now I can come down into my game loop, and I can add these in. I'm going to call the draw text function. The text I want to put in is CPU : space plus the string. Remember, you have to convert it to a string when adding it to existing text. This is going to be my CPU score. The font that I have to feed in, I've already defined, and the variable for that is font. The color is going to be white, which I've defined, and then the x coordinate and the y coordinate. Now I can just copy this down and do the same for player score. Just going to call that P1 string player score. Font is the same color. And now I want this to be coming over from the right hand side, so I'll say my screen width minus 100. Alright, so now I'll test this. Okay, so that's looking a bit better now. I've got the score counters displayed at the top. Alright, so the next step is to add in my paddles. Now for this, I'm going to define a separate class up here. I'm going to call it class paddle. And as always, it's going to start off with the initialization function. So in it, I'm going to feed in self, and all I need is an x and a y coordinate for this to start with. So as normal, I'll just type this out, self x equals x, self y equals y. Now I want these paddles to be rectangles, so I'm going to use the built-in rect function within PyGame. So this is going to be another self rect equals rect. I'm going to take the x and the y coordinates that it feeds in, and I'm going to give it a width of 20 pixels and a height of 100 pixels. So that's how big each of the paddles is going to be. And I want to give it a speed as well. So self speed equals 5. And because I'm going to be coding this in with AI, I'm going to be adding AI variables into the same class. So I'll add in AI speed. Now it's going to be the same, it's going to be set to 5, but I'm going to keep the variables separate from each other, as it just allows a bit of customization if you want to ever change any of these as you go. And the next thing to do is define a move function. So define move, and this is what's going to move the paddle up and down. The first thing I want to do is get the key presses. So key equals, and again, a PyGame function for this, key.get_pressed. So this is going to tell me which buttons have been pressed. And now I can process that to determine whether to move the paddle up or down. Now I'm going to be assigning my movement to the up and down arrow keys. That means that I just need to look for if key, and we put in square brackets, pygame.k_up, so key up, close brackets, then all I want to do is move that rectangle. So I'm going to be adjusting the y coordinate of the rectangle. I'm going to use the rect. Remember, rect is the rectangle that I've created earlier for this instance. Rect.move IP. So that means move in place. I'm going to leave the x coordinate as is. So there is no x movement, meaning I'm going to leave it as a 0. And then I'm going to move this by self speed. So 5 pixels is how quick I want this paddle to move. Now because it's moving up the way, it means that the y coordinate is decreasing. So I will say a negative of self speed. So -1 multiplied by self.speed. Now I can copy this down and do the same thing for the down key. So if I press down, well, I move it in the same way, but I increase the y coordinate now. So it moves by plus self speed. The one thing to notice here is there's no limits on this. So essentially, if I just keep holding up or down, the paddle's just going to go off the screen. So I need to add these limits in myself. So I'm going to come into this initial up key. So if I'm pressing up, I only want the paddle to go up as high as the margin allows it to, which means that if the top of the rectangle comes in contact with the margin, I don't want it to move anymore. So this is where I'm going to add an AND statement. So if the self.rect.top, meaning the top of the rectangle, if that is above the margin, right, because this is these are y coordinates, so up greater than means it's below, because the y coordinate increases as you move down the screen. So if this is below the margin, then we're allowed to continue moving up. Likewise, I'm going to add an AND statement here, but it's going to look at the bottom of the rectangle. So if this is less than screen height, then I'm allowed to continue moving, but as soon as I reach the screen height, then I stop. So I've defined these functions. Now I just need to add a draw function so I can actually display this on the screen. So define draw, and all it's going to take is self, and I'm just going to call again the pygame.draw. So this is the function I mentioned earlier. You can draw lines, circles, ellipses, and I'm just going to call the rect draw. So I'm going to put it onto the screen. I'm going to give it a color of white, which I've defined before, and I'm going to tell it to draw the instance rectangle. All right, so I've defined the class. So now all else left to do is call this class out. Now notice I haven't actually added any AI code into this. I'm going to come back to that later. In the meantime, I just want to create the paddles and make sure that's working. So I'm going to create a player paddle, for which I'm going to call that class. And I need to, if we go up here, I need to feed in an X and a Y coordinate. So these are the start points for this paddle. I've chosen this already. So this is going to be my screen width, because remember I'm drawing this player paddle on the right hand side, so it's going to come from the end of the screen. And I'm going to put it roughly in the middle. So screen height divided by 2. Now I used 2 slashes here, so this is going to give me an integer value. It's going to round down completely. So that's going to create the player paddle. And actually I'm going to add a little comment here, create paddles. And the next one I want to do is the CPU paddle. So more or less the same code, and in fact I'm just going to copy it down. The only difference is I want to change my X position. So the X is going to start at 20. Alright, so now now that I've created these instances, I can call them within my game loop. I'll come down here and I'll say draw paddles. So if you remember, I added in a draw function into the paddle class. So all I need to do here is just call that. So I'll say the player paddle dot draw and CPU paddle dot draw. So that's going to display both of the paddles. I'm going to run this just to see if it works. I've made a typo on screen. Try again. There we go. So it's drawing the paddles. I'm just going to try moving it, and it doesn't seem to be doing anything yet. So I've missed something. So let me just check. Okay, so I've called the draw function, and that's just displaying it, but I haven't called the move function. So I'm going to come down here, and I'm going to add move paddles, player paddle dot move. So I'll try that. Alright, there we go. So I'm able to move this. Now you'll notice it's limited by the margin and the bottom of the screen. However, it moves pretty much instantly. And the reason for this is it's just running as fast as the computer can process it. So there's no frame limit to this. And that's something that I need to add to make sure that the game is actually playable. So to add this, I'm going to come all the way back to the top. And where I've defined all these screens and the variables, I'm going to create a clock. So I'm going to call this my FPS, frames per second clock, and I'll use the built-in PyGame.clock function. So I'll come down here somewhere where I've got my variables and my font, and I'll actually define this now. So set I suppose I can put it into my game variables. I just want to set a frames per second limit. So FPS is going to be 60. Now I come down into my main game loop, and right at the start, I call that clock. So that was FPS clock dot tick at a rate of FPS. And let's try that again. And you can see that's a lot smoother now. So it's actually waiting and it's processing this game, or it's limiting this game to 60 frames per second. So the movement of this paddle is much smoother. So now that I've got the paddle set up, the next thing I need to do is create the ball. I'm going to do that in the same way, and I'm going to create a ball class. So I'll start this with defining an init function. I'm going to feed in self, x, and y. So more or less the same as the paddles. So self x equals x, self y equals y. And I have some additional variables I want for this. I'm going to give it a radius. Self ball radius equals 8 pixels. And I'm going to give it a speed. So much the same as up here. And in fact, I'm just going to copy this down. So I do want to create a rectangle from it. So I'll keep this. And the rectangle is going to be x and y, but the width and the height are going to be the same because I'm trying to make it a ball. So I'm just going to use the radius times 2. So although it's going to treat it as a rectangle, when it comes to drawing it, I'm going to output a circle. And now I want to add 2 conditions for speed. So an x speed and a y speed. Now to start with, the player one is always going to be the one that starts. So the ball is going to move from the right to the left, meaning that the x speed should be negative as it moves in the negative direction of the x coordinate. So I'll start as -4. Speed y I'm going to make the same, but it's going to be a positive. Speed y equals 4. So now, much like the paddles, I'm going to add in a move function. So def move. That's just going to take the self variable or safe argument. And I suppose for movement, I need to be looking for the same kind of parameters. The ball can only bounce off the top and the bottom of the screen. If it goes out of the left and right past the paddles, then it's game over, and then it needs to collide with the paddles themselves. So first of all, I'm just going to add in normal movement for the ball. So update the ball position. And all that's going to be happening is I'm going to be updating the rectangle x and rectangle y coordinates every iteration. So self.rect.x, which is being defined, well, is defined by the position of that rectangle which has been created. So this is taking the x coordinate of that rectangle. I increase that by self.speedx, which again has been defined. And I'm going to do the same thing for the y coordinate. Speed y plus speed y. So this is just going to be automatically increasing the speed of the ball. Or rather, it's going to be adjusting the position of the ball based on the ball's speed. Next, just as I did up here, I need to define a draw function so that I can actually display this ball onto the screen. So pygame.draw, but this time I want to draw it as a circle, which means it takes more or less the same coordinates, same arguments, screen, and then a color, and then I need to give it an x and a y and a radius. So the x and y is going to be taken from the rectangles x and y, which I already have defined up here as it moves around, rect.x. However, that's going to give me the top left corner. So I want to move, or rather I want to draw this circle in the central position. So I need to give it the radius. This is going to be self.ball rad. I need to do the same for the height. Self.rect y plus self.ball radius. Start. And now I need to give it a radius. Self.ball rad. And this is the thing with working with classes, is that you have to keep putting in self in quite a lot of places. Alright, so this is going to give me my very basic setup for the ball. So now I need to create an instance of it. I come down here and underneath, I want to create Pong ball. So I'm going to call this Pong equals ball, because I don't want to call it the same as the name of the class. And I'm going to give it an X and a Y. Screen width -50. So it's going to start over on the right hand side next to the player paddle. Screen height divided by 2 plus 50. So it's somewhere in the middle or a bit further down on the screen near the paddle. Now I can come down to my code and begin drawing that ball. So where I've currently got the paddles, I'm just going to draw it in here. So draw ball, and I'll call that function from the class. So pong.draw. Okay, so that was quite a lot of typing. I'm going to run it just in case there's any errors along the way. Okay, seems to be fine. It's created the ball. The ball, however, is not moving, and that is because I've not called the move function. So I'll add that in just above pong.move and try that. Ah, there you go. Okay, so I mean, you can see for a very short amount of time it does work. The ball is generated and then it starts moving in this direction, but I haven't added any collision. So the ball is just going to move off the screen, and that's pretty much the end of it. So that's when I'm going to come back into this ball class, and I'm going to add that collision into the move function. So the first thing I want to do is look for collision with the top and the bottom of the screen. So I'll say check collision with top margin. Now I've already defined this margin variable in my variable get definitions. So I know that that's 50 pixels from the top of the screen. So I'm just going to be looking for the top of my rectangle and ensuring more or less as I did with this move function here that it doesn't cross over that margin line. So I'll say if self.rect.top, so the top of the ball, as long as it's less than margin, or rather, because this ball is moving automatically, if it was to cross the margin line, all I want to do is make it bounce off it. So if you remember, I've defined a speed x and a speed y. So the speed y is moving the ball up and down. So if it's hit the margin, then it means the y speed is currently negative as the y coordinate is decreasing. When it comes in contact with the margin, I want to flip that from negative to positive, so it starts moving in the opposite direction. So all I need to do for that is just multiply it by -1. So self speed underscore y multiplied goes by 1. Oh, sorry, -1. So that's going to flip it around. And now I do the same thing for the bottom of the screen. Check collision with bottom of screen. Okay, so now I'm looking for the bottom of the rectangle. If the bottom of the rectangle exceeds the screen height, then I want to do the same thing. I just want to flip the y coordinate. And now the last thing I need to add is collision with the paddles. And the way that the rect function works, it's going to make this much easier for me. So I'll type it out and I'll explain what's happening. So I'm going to look for self.rect.collide rect. So what's this taking? It's taking self.rect, which is going to be whatever instance I've created. So it's going to be that ball rectangle. And then it's going to use this collide rect function, which is just looking for an intersection between this rectangle and whatever I put in here. And what I'm going to put in there is my player paddle instance. So it's going to take the player paddle and it's going to look for a collision against the ball rectangle. So if that's happened, or if I copy the same thing over, if I've had that same intersection but with the CPU paddle, well, in both of those cases, the outcome is the same. I'm going to be flipping the x coordinate this time. So if it's moving to the right, that means the x speed is increasing. As soon as it hits the paddle, it needs to turn negative. So that's what this is doing here. And lastly, I need to be able to check if it's gone past the paddle and it's gone off the screen. So now I'm going to look for check for out of bounds. And this is more or less the same thing. But now instead of looking for top and bottom, I'm looking for left and right. So if self.rect.left, so if the left-hand side of the rectangle is less than 0 on the x-coordinate, I'm going to be defining the winner at this point rather than flipping everything around. So this is going to be a new variable, and this variable is going to be within this class. So actually, before I type this out, I'm going to come into my self or my init function here, and I'm going to add another variable. And this is going to be self.winner, and I'll set this to 0. And I'll add a comment to explain this. So 1 is the player, and -1 is the CPU. So that's going to allow me to set who has won based on this out of bounds condition. So if we've gone off the screen on the left-hand side, well, that means that the player has won because it's the CPU that's missed the ball. So winner is 1. Now I do the same check. And now I put in, if I go off the side of the screen, so if I go off screen width, the winner is -1 because it's the CPU that's won. Just tidied up some of this empty space. All right, so what I want to do now is I've got this winner variable, but I need to feed this back. So my move function is going to be the one that's going to be handling this. Therefore, that's where I want that to be coming back from. So I'm just going to return self.winner. So if I now call this within the main loop and I equate it to something, it's going to give me a 1 or a -1 when this one of these conditions is met. So let's just test this again in case there's anything going funny. And straight away there is. The ball starts off here and then it kind of goes off the screen. So that's to do with the collision, and it seems to be bugging out a little bit. It seems to just be going off the screen. And I think what's happening there is that I've created the ball within the paddle, so it's kind of getting confused. It's starting off with an immediate collision. So maybe if I move this over to the left a little bit. Okay, that seems to be better. So that worked. The ball came off here, it bounced off, went past, and well, nothing really happened. I haven't coded that part in, but at least the collision initially is working. Okay, but two things are happening here, or rather, two things are not happening here, which is that I have no control over when the game starts, and once the ball has gone out of bounds, nothing actually happens. So I'm going to add in a couple of things. First, I'm going to add in a section within the main loop that allows me to control the start of the game. So where I already have my event handler, all of the moment I've got is for handling exiting. I'm going to add in a mouse click. So if event.type is PyGame.mouse button down, which means the mouse has been clicked. And now what I want to add is another variable which is going to control whether the game, or rather whether the ball is in play. So if I come back up here, I'm going to add a new variable which is going to be live ball. And I'll start this off as a 0, or rather I'll make it a boolean. So I'll start off as a false value. Then I can come back into my game loop, and if live ball is indeed false, well, the game has not begun yet. So as soon as I click the mouse button, I want to say that my live ball is set to true. So the game can now begin. And at this point, I want to be able to first kick off that ball, but also in the future when a score has been set, so either the player scored or the CPU scored, I want this to be repeated so that I can use this clicking to reset the ball every time. Now, because I've defined a class for the ball, and then I create the instance of it, I need to add in a way of actually resetting it. I don't want to simply redraw that ball back at the start of where the paddle is. I want to actually reset all these variables. So I'm going to do that by defining a reset function. And this reset function is more or less going to be my initialization function, because that's essentially what it's going to be running every time. So I come down here, I say define reset, and I'm going to give it the same variables as what I've given my init function up here. So x and y. And into it, I'm just going to copy all of these. So every time we reset, we want to reset all these variables again. So now how do I call this? Well, my instance is always going to be defined by, or we're going to start off with this constructor. So I'm just going to add a function within here to call reset and to give it the x and y coordinate, meaning that whenever I create this instance, or whenever I call this instance, it's going to run the reset function, going to give it the x and y coordinates that I've supplied, and it's going to set these variables. So that's going to be the initial initialization when I create the instance here. However, it now means that I can call this function within the main loop whenever I want, and it's going to reset all the variables for me. So it's going to reset the original ball back to 0. So I come back down here, and where I've got the live ball, I can say pong.reset, which is that new function I've created, and I'm going to give it the x and y that I set here. So I always wanted to start at that same point. Alright, so let's test again and see what's happening. So it's still bouncing. Now I'm not, you see, I can reset, as long as I've gone off the screen, I had the option to reset once. Except now, my variable has been set to true. So I can't do it anymore. So I need a way of resetting that back. And that's going to require a bit more logic within the game. So at the moment, all I've got is I'm outputting some text, I'm updating my paddles, and I've got some event handling. So I'm going to add in some logic for what's actually happening when the ball goes out of play. I'll create a new section under here. So I still want my paddles to be updated first, and then I'm going to add a section for what happens once the ball is in play. So if live ball equals true, so once the game is started, I'm going to be wanting to move the ball at that stage. So I don't want to just be moving the ball constantly, but once the game has started, I want to call that pong.move function. And now remember, this pong.move at the same time is going to be handling all of my collision. It's also going to be handling whether or not we've gone off the screen and one of the players has won. So it returns a winner. So if I come back down here, rather than just calling that function, if I actually look for the winner variable, if I ask who is the winner, then it's going to tell me it's going to be 0 until it's gone off the screen. So as long as winner is 0, meaning that the ball is still in play and no one's won, well, in that case, I want to keep updating the ball. I want to keep moving it because the game is still ongoing. I also don't want to be able to move the paddles when the game's not going, so I'm going to move this here as well. So essentially, as long as the game's running, all of these commands or all of these functions can be called. However, if someone has won, then we want to set the live ball to false again. We want to reset that variable. And now I want to look for who has won. So if the winner that's been fed back from that function is 1, then that means that the player has won. So all I can do is increase the player score. So player score plus 1. However, if the winner is -1, meaning the CPU is 1, well, I just say CPU score. Oops. It's plus equals 1. No, I'm getting mixed up. If winner is -1, then CPU score plus equals 1. Alright, so let's try this now. And it kicks off and the ball's gone out of play. You can see player 1's score is increased. I'll try again. I'm able to generate. So now the live ball should have been set to false when I click, should have been set to true when it went off. There you go. So I'm able to just keep spitting these out and I can move the paddle up and down. But of course I haven't coded in the AI, so the other paddle isn't moving and it's not responding. So that's what I'm going to add in now. It's actually quite straightforward because the AI that I've created in this game, it's not particularly intelligent. All it's going to do is it's going to follow the position of the ball up and down on the screen. So it's going to move more or less with the ball. So underneath this, I'm just going to add an AI function. It means that I can call this separately. That's why I'm adding it as a separate function. So if I don't call this, then there is no AI control of that paddle. I'm going to give it self, and I'll say AI to move the paddle automatically. And I'm going to first of all look for the condition when it moves down. So what I want to be looking for is if the center of the paddle, because I want this to be kind of around the center line. So if the center of the paddle is going above or beyond the ball rectangle, then I want to move the paddle to compensate for that. So if self rect, so remember this is the instance, in which case this is going to be the instance of the CPU paddle. So that's going to be that rectangle, center Y. So that's going to be the Y coordinate at the middle of the paddle. If that has gone less than, meaning that it's above because it's a Y coordinate, if that has gone above the Pong, so that is the instance of the ball that I've created, ball rect top. And at the same time, I want to make sure that this doesn't go off the screen, right? So I need to check that the rectangle or the paddle has not gone off the bottom of the screen. So, and self.rect.bottom is less than screen height. Then I'm just going to be moving the paddle. So self.rect, move in place. I don't want to move it in the X direction, so that's a 0. I want to move it in the Y direction. I want to move it down, therefore the Y coordinate increases positively. So again, what am I doing here? I'm saying if the paddle rectangle, so if the center line of the paddle is less than the top of the ball, meaning that it's above it because it's a Y coordinate, then I want this paddle to be moving down. However, I want to add this condition to make sure that it doesn't go off the screen. So it's only going to move down as long as the bottom of it is still above my screen height. So now I just copy this and I do the same thing for moving up. Now I'm looking for the same, but in the opposite direction. So if it's greater than the bottom of the rectangle and the top of the paddle is greater than the margin, so we haven't crossed over the margin and gone on to the scoring area, then we move in place, but we move by a negative value. So with that defined, I still need to call that function. Otherwise, that function is not going to be doing anything within the game loop. So I come down to where I've got my player paddle, and I'm going to add my CPU paddle. But instead of calling the move function, which means that if I call the move function, it's going to look for my up and down keystrokes. I don't want to be able to control that paddle, so I'm just going to call the AI function. All right, so let's just test that. And nothing's going to happen until I click the mouse to start. And now you can see the paddle is moving up and down, and it's bouncing the ball back to me. So with that simple little section, I've added in some fairly basic but robust AI. It's moving up and down, and it's able to play back against you, knocks the ball. And now if I let this pass, what's going to happen? CPU has scored, the game is frozen, and now I need to click to restart. So that's mostly the game created, right? That's the bare bones of it done, and structurally it's there, but there's some information missing. So for example, there's nothing to tell me that I need to click to be able to start the game. And these kind of inputs are important to add. So I'm going to add some more text onto the screen. And this is going to be the instructions to the player. So I'll say print player instructions. Now I want this to be happening when the game is not live. I don't want any text on the screen when you're actually playing. So if live ball is false, meaning we're waiting to start the game, then if there's no winner, so if winner is 0, i.e. the game has only just begun, then we want to call that draw text function, which I defined previously. So this draw text function is going to take the text, the font, the color, and then the X and Y coordinates where I want to display this text. So I come back down here. If no one has won, i.e. the game has only started, draw text. And I'm going to say capitals, click anywhere to start. And next I want to give it the font, and I've previously defined that font simply with the variable font. The color I want is white, and the X coordinate is going to be 100, and for the Y coordinate I want it to be not straight in the middle. I kind of want it to be a little bit higher up than that, so minus 100. But what if somebody has won? I still want the same thing to be happening more or less, because the live ball at that point is going to be false. As soon as the game is over, or as soon as someone scored a point, live ball switches to false. So let's say the player has won. Then I want to draw text saying you scored. It's going to be font, white, and the coordinates for this I've predefined before. So I'm going to say 220 pixels, and the Y coordinate is going to be more or less in the same place. But now I want that instruction to be copied. So I add that back in here again. So draw text, click anywhere to start, font white. But this time I'm going to have it a little bit lower down so it doesn't overwrite that other text. Now let's copy this across for if the CPU wins. If winner is -1, well, it's CPU that scored. So the X position is all going to be the same, and all of these are going to be the same as well. So you can see why adding or creating this draw text function in the first place was useful. Although it's only a couple of lines, it does save a bit of time, because normally what I would have to do is create that text as a text variable, then I convert it into an image, and then I would blit that image onto the screen. So you see that I would have to do this 5 times here, 2 times there. So it saves a bit of time creating some of these variables. So let me just test this and make sure it's working. And it's not because I have not defined this variable yet. Of course, that's the important thing. So winner is the product of that function. However, I need to actually define this as my system variable first. So I'll come back up here and I'll set it to 0 to start with. I'll try again. All right, so I've got an instruction, click anywhere to start. As soon as I click, the instruction disappears. Now I'm going to let the CPU win. CPU scored, click anywhere to start, and the ball is issued again, and everything repeats. So it's coming together a bit more now. There's a bit more structure to it and a bit more player feedback. So the very last thing I want to do then is add a little bit more of a challenge to the game. And I'm going to do that by altering the speed of the ball. So if I come back here, I defined it initially as 4. So it's 4 in the y direction and 4 in the x direction. So it's the same speed. I'm going to make sure that as the game progresses, it gets more and more difficult. So I'll come in here and right at the end of the game loop, I'll add a speed counter. So I don't want the speed to constantly be increasing. I want it to be happening after a certain number of iterations. So I'll say I'll define my speed increase variable first so that it doesn't throw an error after. So speed increase equals 0. And now as long as the game is in play, meaning as long as there's a live ball, I want that speed increase counter to be adjusted. So speed increase is increased by 1. So as long as the game's playing, speed increase is going up. And I'm just going to add a condition for when we get to a certain count, that's when I want the speed to go up. So if speed increase, and I'm just going to say 500. If it goes beyond 500, then I want to reset it back to 0. I'll copy this down. And I'll say that's becoming 0 again. And now I can adjust the speed of the ball. So I'm able to do that because the ball is created as an instance. So I'm able to access the instance's variables, such as the speed x and the speed y. And that's what I'm going to alter within this section. So if the ball is moving left or right, I'm going to adjust the x speed, and for up and down, it's going to be the y speed. But I need to be sure, first of all, of which direction it's moving in. So I'm going to say that if Pong, which is the instance, or the name of that instance, speed x, so the speed in the x direction, if that's less than 0, meaning that it's a negative direction, then to increase the speed, I don't want to add to it because then it's going to slow it down, right? It's a negative. So I need to take a number away from it, and that's going to further speed it up. So Pong speed x minus equals 1. Now I can just repeat this to say, okay, well, if it's moving to the right-hand side, then the speed must obviously be positive. So if it's positive, then to increase it further, I need to add 1 to it. And now copy this across, do the same thing for the y coordinate, or sorry, the y speed. If Pong speed y is less than 0, oh, I skipped one. If Pong speed y is less than 0, then we take 1 away. And if it's greater than 0, then we add 1. All right, so I think that's defined. Let me just check. Oh, so of course I'm not displaying this on the screen anywhere. I've only got the CPU player 1 and then start instructions. So I need to be showing this on the screen. So I'll do another line, draw text. So again, using that function that I created, ball speed. And to this I'm going to add, I need to convert the ball speed to a string. So string Pong speed x, which of course x and y speeds are going to be the same, they're increasing together, so it doesn't really matter which one I display. Now the issue here is going to be, it could sometimes be negative just because it's moving in the left-hand direction. I don't want it to display as a negative, so I'm going to use the absolute function. So it doesn't matter if it's negative or positive, it's always going to give the positive value. And then I want to give it the font, so just the same as what I've done above. The color, I'm going to put it kind of in the middle of the screen, but that's where it's going to start, so I need to shift it over to the left. And 15 down from the top, just the same as the rest of the text. So I'll just check if that's worked okay. There we go, I've got a ball speed of 4 at the top. And now I'll just play for a little bit, and this ball speed should increase to 5. Still playing. There we go. And you can see notably the ball has instantly sped up. So essentially that's just going to keep going until either I make a mistake or the ball speed increases so much that the well, I made a mistake. But because of the way the paddle moves up and down for the AI and it's moving the ball around, eventually the ball is going to be so fast that the paddle can't actually keep up with it because I've limited the CPU speed. So that's where that variable that I discussed in the paddle class comes in, right? So I've set separate speeds here. It just means that it doesn't have to be set like this. You can adjust it and tweak it as you wish. And that's pretty much it. So That's the game created from scratch, and you can see we've got some control of the paddle. We've got AI built into it. So that was a pretty quick run through of how the game was created. So if you guys want to see more videos like this, then feel free to subscribe. And if you have any questions or comments, then just leave them down below and I'll respond to them. So I hope that was useful and thank you for watching.